Another draft physics video presentation. The Van Biezen series of videos, getting towards the end. So this on color. Now this video doesn't say much, 2 minutes long. You really can't say much about what color is. But what they don't say, he gets into heat, which is sort of the important subject, I would argue. Turn on the light. Yeah, that helps maybe. Maybe. Alright, so photons. Yeah, photons are the kind of an essential source of momentum in the universe, I would argue. And physics, conventional physics, never really talks about it. So they recognize that this frequency thing's important, but they've made the frequency into some sort of wave in two different dimensions or two different fields, or somehow oscillating, and call that an elemental function, which doesn't make much sense. I mean, an oscillation is not an elemental function. I mean, little bit on, all the way on, little bit on, off, this kind of thing. And this isn't even on, off, it's a reversal in a field. And there's nothing necessary about any of this sine wave function. I mean, there's no evidence that a photon comes in gradually increasing amounts and then diminishing amounts or any of that kind of thing. It's a clump, okay? A clump of energy, a quanta of energy is a certain amount of photon. So, but they sort of recognize to some extent that phase is important. That is, if it isn't on phase, if, for example, you sent a photon that had, one wave that was this, and the next wave was a much longer wave, that it had a more than one frequency built into it, or wavelength. They don't talk about that subject at all. Like, that can never happen. A photon can never be broken by the simple breaking of its phase. They think it's destroyed if that happens. It's consumed, it's something. There's just no recognition that that's a regular function. And for example, in the light polarization thing, where you have the filters, and you cross the filters, and then you put a filter in between the middle, go in the in-between direction, that you end up with more light, even though you added a third filter, kind of indicating that somehow you're restoring photons that somehow were not detectable otherwise. As I've pointed out, that's the simple explanation for the function. They don't talk about that. So the photon did exist, it's just that the phase was broken. This little bit here was moved to here, let's say, and this can't be understood by any of the mechanisms we use to detect photons. It can't detect these photons when they're out of sequence. And they never talk about length of a photon. How long is this ray? How long is this wavy thing going? They never talk about that, ever. And I'd say those are essential parts of understanding why a photon does create heat. So it's not directly related to color, except in the sense that you can understand that this is a different color than this, and the key factor being that if you don't have enough of a consistent frequency, that you need a certain amount of this ray length to detect the photon, and the ray length has to be a consistent frequency. And if it's out of that consistency, it has a different consequence, like heat, for example. Alright, so that's the premise here. There's just no conversation about what photons really do in the world, in terms of understanding how they come in these different forms, and what if they're broken, or what if they're in little tiny ray lengths. What is all of that, and how do they account for any of that existing? They just assume somehow it doesn't. Like, photons either are or are not, and then if they aren't energy. They couldn't be possibly something like gravity, or be a cause for other effects we see in the universe. And glaring error on physics' part, clearly incomplete in terms of their knowledge, and yet they won't concede that rudimentary, fundamental incompleteness.
Welcome to Electron Line. Now we're going to take a look at the photon from a different perspective in how it creates color in the environment around us and how we see color. So let's say we have the sun over here that looks yellow to us for various reasons. And so the sunlight that finally reaches the Earth will of course contain all the various colors of the rainbow, from purple to blue to green, yellow, orange, and red. And so why does a stop sign, for example, look red, and why does the ocean seem to look blue, and why does the sky look blue, and all those various reasons? Well, in the case of objects themselves, they look a certain color because of the light that they reflect and the light.
So this is sort of a, not a very good way of saying it, where he's making comparisons between objects that reflect light and objects that emit light, which are different, and of course objects that end up scattering light over large areas. The reason why they're colored is different reasons, like the absorption rate of the stuff you're passing the light through. And the reason why the sun's yellow is partly because of that. It's lost some of the blue, and so it's gone more yellow because more of the ultraviolet light has been pulled out of it through the atmosphere. But anyway, continuing.
That they absorb. So sunlight, which contains all the various colors of the rainbow, will be incident on a stop sign like this. And what happens is that the vast majority of the photons actually are absorbed by the sign, and only the red light is being reflected. So that's why the stop sign will look red. Now, why do the letters look white? Well, it turns out that the letters are made of a certain paint that reflect all the colors of the rainbow. And of course, when you see all the colors of the rainbow together, then that light will then look white. So white is simply all the colors combined. And red.
So no real explanation that these are just pigments, okay? They're not the substance of the object. They're a tiny amount of the mass of the object. And yet, because they're on the surface, okay, so that accounts for part of the fact that it's a low in mass, but also that their quality is that they're very reflective in the first place. That they are capable of reflecting the photons that hit them. Most of them bounce off.
Red is only the red being reflected and the others being absorbed. Now, of course, when sunlight, hits a stop sign, when all those other photons are absorbed, the stop sign will get very warm, and then, of course, the stop sign would then radiate out that heat in the form of electromagnetic radiation consisting of photons of longer wavelengths. In this case, it would be the infrared wavelengths. And the wavelengths of those photons would be equal to 0.0029, which is a constant in Wien's law, divided by the temperature of that stop sign. So as more and more sunlight is incident on the stop sign, and only the red light is reflected so that the other colors are absorbed, the stop sign will get warmer and warmer. As it gets warmer, it will continue to give off wavelengths of shorter and shorter wavelengths, carrying away more and more energy from the stop sign until the incident energy of the sunlight equals the exit energy of the radiation coming off the stop sign.
Right, so I don't know if there's a simpler way to describe that, but I mean the more complex explanation, of course, is that all these substances, every chemical has absorption lines. I mean, places where it doesn't reflect because it's the frequency that the atoms, are most likely to absorb the energy in a form where they move the electrons, and if they don't displace an electron a proper distance, then the electron just moves back to its position, and that's essentially saying I'm putting the surface back where it belongs. And so that's the reflection, in the sense that it's sort of what I drew in the other video, where the wall that is the electron moves from one position to another position. It means that any energy that hits it from the external world is going to be changed in the fact that it's going to reflect at a different time, right? So if I move something closer to something heading for it, it's going to reflect at a different time than it would if the thing was here. And that's essentially, what's creating photons is the movement of electrons, and the change in their position effectively is creating the frequency of the reflected force.
So then the stop sign will reach an equilibrium point in temperature so that the incident energy and the exit energy is equal to each other. But the reason why the sign looks red is because it's only the red photons are being reflected and all the other photons are being absorbed. Again, photons is what allows us to see color.
Right, absorbed and emitted in a form, okay, that has a lower wavelength because the electrons move slower than the thing that moved them. So they move back slower than they were pushed by the energy of the photon. And so the difference is in the speed of moving this direction faster than you move back, I would argue. Alright, so we'll play this a second video.
The selectivity of which photons are absorbed and which
short.
photons are reflected. And the reflected photons is a
Okay, well, let him finish.
color that we end up seeing. And that's how that works.
Right, so there isn't much of an explanation of how it works. Nothing, he didn't get into the energy levels of the electrons, the fact that you're hitting different electrons and those are the different energy levels that can be absorbed, and that it's a very specific which frequencies are being pulled out, you know, and the ones that are left to reflect. So we'll go to 40, is that it? I'm on 39. I'm on 37 and they give me the choice of 40. Well, that's disappointing. That's really disappointing. That sucks. Alright, so I have to do something. Yeah, so I guess I'll pause and find the right video because YouTube couldn't do it for me. Alright, that wasn't too difficult. He actually has the link to the next video in the description, which is very helpful. Thank you.
Now we're going to learn something about photons and how they cause sunburns. Now, the photons that cause sunburns are the photons come from the sun that are UV radiation, ultraviolet radiation. And here we're going to learn why that is so, why UV radiation causes sunburns, and what it is about photons. Remember, photons are little packages of energy. So when sunlight arrives around the Earth and comes to the atmosphere, a little bit of the UV radiation comes from the sun actually makes it through and will hit our skin as it's exposed to the sunlight. Now, it turns out our skin is, of course, made out of carbon bonds, and carbon bonds can either be single bonds or double bonds, and the amount of energy to rip those bonds apart, the energy required to separate the carbons, will be 348 kilojoules per mole for single bond carbon bonds, and 640 kilojoules per mole for double bonds. So
they're essentially just doubling it, right? 300 and 600. And the idea is there's two electrons that are being shared versus one electron being shared. And I would argue they're literally shared. They're not orbiting and doing all that other crap that they made up. But whatever.
let's find out what the energy is required to break a single bond. And the way, of course, photons would cause those bonds to break is when a photon comes along and hits our skin. The photon, as it reaches our skin, will cause electric field and magnetic field oscillations that...
Again, there's no evidence for these fields existing and for them to oscillate anything or any of that. So this is just their story they've made up to explain it. I would argue it simply hits it. And by hitting it, it exchanges momentum. That is, part of the momentum is absorbed by the electron and it moves. And it's not like a part anyway. It's, I just, might as well draw it real quick, right? I mean, the idea is the electron is the thing, okay? The energy comes in the form of a photon. One little quanta of it has the capacity to basically be, the photon is an arrow. The arrow goes in the sense that it's a piece of momentum. The electron has already got a bunch of momentum in it, okay, that's moving in all these directions. Like this was a, you can just imagine the electron is a membrane. And, you know, what little ricochet rabbits go into it, okay? The little rabbit goes in its origin, okay, to start making an electron, whatever. It's basically just bouncing back and forth. And the more speed it has in a direction, the more that bouncing will mean that it spends a lot more time going this way than this way. Because obviously as this thing moves through space, right, it's going to... if something was trapped inside of it, it would move this way, okay? But the back end is moving while it's moving that way. So the back end is getting closer and closer, right? So the back end started here, but the back end will be here and then here. And then it just goes a little bit this way to reflect again and go along this way. And that's how momentum is held inside of electrons, I would argue. I think that's a reasonable guess. Makes sense, fits the evidence, all of that stuff. And so all you're really doing is taking a bit of energy, putting it inside the electron, and exchanging it for what you're going to be replacing, which is some other piece of energy, obviously going the opposite way. So you you throw something in going this way, and while you're doing that, this one sneaks out the door. So one thing goes in, something else comes out, energy is conserved, clump is conserved essentially, and so this new clump is in here doing the same thing. And you can just imagine if there's ones bouncing in different directions, and that's all that's inside of an electron. If it has a bias in a direction, it's because more stuff went in a direction originally. So it's the original movement that decides the movement. The first throw is always conserved, and it always keeps reoccurring. And so you end up with something that goes through space, stops, goes, stops, goes. Because what you're basically saying is you threw something in, you throw something into the container, its first hit moves it, it reflects off the surfaces, hits the other surface. When it hits the other surface, it's not going to go the opposite way, it's just going to stop. And then when it hits this front surface, it's going to move again, and then it's going to stop, and then it's going to move again, and then it's going to stop. Anyway, so that's a little bit of context. I would argue that description is much more complete than their vibrating field thingies, blah, 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 blah.
Cause forces to exist on the electrons that it comes in contact with, or that it passes by basically, and that causes those electrons to oscillate up and down, causing them to feel a certain amount of force. And
Alright, so again, understand the photon is gigantic in its dimensions compared to the size of the electron. The photon's polarization essentially proves that the photon has a substance that's spread over a great deal of distance, 2,000 atoms worth. And that the electron is a tiny part of those atoms, so obviously it can't be interacting personally with one electron. One photon can't personally interact with one photon. Can't really happen that way.
Force is sufficient. In other words, if the energy contained within the photon is sufficient to cause the motion of the electron to be so violent that it can actually break the bonds in the carbon chains. And that is what it then.
So the more, I'd say, the more rational explanation. Yeah. All right, so they're just saying, oh, it's vibrating so fast that it flies out, but that's not saying anything, right? So again, the only reasonable explanation is to recognize that why frequency matters is because of this tipping point argument, a pendulum swinging kind of argument. And the idea is that you have to hit the pendulum while it's moving in the direction you want it to go faster in, and then if you do that, you can add more and more energy to the pendulum and get a bigger and bigger swing out of the pendulum and break it free. So you're really just talking about a standard tipping argument in a sense, where you hit something and then you wait for it to vibrate, and then when it's going the way of your motion again, you hit it again when it's in this position, and then all your energy is added. Then you're adding energy. You have constructive addition of energy. And then it's obviously going to be destructive if you hit it when it's coming back. Then you're going to slow down its rocking motion. You're going to make it more stationary if you hit it destructively. So it's not really constructive and destructive. It's really, are you adding or are you subtracting motion from the object? Are you causing it to move further, or are you taking energy out of the system, just like pushing a kid in a swing? So I mean, you have all these simple ways of understanding when frequency is really important. And this is how it's really important, is in terms of adding more motion to a system or taking motion out of a system. It's not simple words like constructive and destructive. It's adding and subtracting energy from the system. Energy in the form of motion. distance.
Cause what we know as a sunburn. So let's find out what the energy is to break a single bond if it's this many kilojoules for a mole of bonds. Of course, a mole would be an Avogadro's number of bonds. And so we then take the energy here, that would be 348 kilojoules per mole, and then we multiply that times 1 mole divided by Avogadro's number of bonds.
So again, they just do this calculating thing like, okay, fine, we understand that there's going to be a relationship between how many photons and how much energy it is, but it doesn't explain any of the elemental functions. So he just gives you this crap, theory that this wobbling electron represents a certain amount of energy and the bond will break. So it's completely ambiguous. It doesn't really explain that, oh, you're adding energy to the system or subtracting based on the wavelength of the frequency. Obviously, the frequency is too high or the frequency is too low. You're not going to add energy to the electron, and the energy you're adding is really the energy necessary to move at a certain distance from the proton.
Okay, so how much would that be? So we take 348,000, because kilo means 1,000, divide by Avogadro's number, which is 6.02 e to the 23rd, and that gives us 5.78 times 10 to the minus 19 joules. Now if we convert that to electron volts, so 1 electron volt is equal to 1.6 times 10 to the minus 19 joules. So we take that number and we divide by 1.6 e to the 19 minus, we get 3.61 electron volts. So if the photon contains this much energy, it can actually break a single bond between 2 carbon atoms.
So again, this is just a way of one way to formalize an explanation of what the frequency needs to be. Because when he says this energy number, he's not talking about the amount of photon or anything else. He's talking about frequency, because they've turned frequency into momentum. And that's all that really represents, is the speed, a minimum speed you need to keep adding energy to the system. You could be faster, but you can't be slower.
How much is that compared to visible light or UV radiation? Well, we know that the energy contained within a photon is equal to the Planck's constant times the frequency of the photon, which is equal to h times the speed of light divided by the wavelength, because remember that the speed of light is equal to the frequency.
So just understand, they've taken momentum out of the equation, the standard for momentum, which is mass times velocity, and just changed it into frequency. So it's just another, it's a huge error in physics to think frequency is momentum when it isn't.
Frequency times the wavelength, so the wavelength is c over f.
It's only relevant because it's not the bullet's fault that you don't fire them in the right rate to knock something over, right? So you have to fire them in the right rate to knock something over. The bullets have the same amount of energy. You haven't changed their energy. All you're changing is that the rate is critical to the function of wobbling something and knocking it over, or adding energy to the system. And it's just it's a fundamental changing of a recognition of what energy is. How else to say it? Yes, it's important. You have to knock them over to be able to see them and for us to account for them. But it doesn't mean you can just pretend that the other energy doesn't exist.
All right, so if we then plug in the numbers here, this is equal to Planck's constant, 6.626 times 10 to the minus 34. That would be joules times second for Planck's constant. Speed of light, 3 times 10 to the 8 meters per second. And then we divide that by the wavelength. Now remember, visible light has a wavelength, so visible light, VL, has a wavelength anywhere from 400 nanometers to 700 nanometers. And the most energetic light would be the purple light at 400 nanometers. So let's plug in 400 nanometers here. 400 times 10 to the minus 9 meters, which would be the wavelength of the most energetic visible light. So I have 6.626 e to the 34 minus times 3 e to the 8 divided by 400 e to the 9 minus.
There'll be no big surprise that the number is going to come up a little short, okay, of the number required.
So that gives us an energy of 4.97 times 10 to the minus 19 joules.
That's
and
more
comparing
than
with electron volts, 1 electron volt divided by 1.6 times 10 to the minus 19 joules. 6 e to the 19 minus.
So
and that
the
gives us
3.4.
3.10 electron volt.
Okay, there
so
you
the
go.
most energetic visible light, the purple light that we get from the sun, contains 3.1 electron volts per photon.
So again, electron volts doesn't really have anything to do with anything other than it's completely dependent on frequency. So they've turned something like voltage into a number representing essentially frequency, when that's not what voltage is. Voltage isn't a frequency. Voltage is an amount of pressure in most cases. So I'm just saying it's just breaking what the variables actually represent, what they mean, to imply that frequency is energy, because it really isn't. How else to say it?
And the bonds required, the strength or the energy required to break a carbon bond.
So again, it's not the energy required, it's explicitly the frequency required to add energy to the system. If you're pushing the kids on the swing at the wrong frequency, that is, you're pushing when they're coming towards you, not when they've stopped or when they're moving away from you. Those are the only times you can add energy. If you push them while they're coming towards you, you'll fail to add energy to the system. It doesn't mean you haven't changed the system. You've clearly changed the system with energy. You've applied a force, a counter force to a force, and essentially equalized and created balance in that element. You could almost argue you've taken heat out of that system. You've made it colder by pushing at the wrong time.
3.61 electron volts. And again, since Einstein proved that photons are the basic quantities of light, light is not a continuous stream of energy, but it's divided into small little chunks of energy called photons, you can only impart as much energy as...
So there's no point in saying something like that. A photon is divided into little chunks that are called photons. I mean, it's one thing, yeah, and you have one stupid word and you're describing two things. So again, he's calling the element of the light, each node, a photon, and then the whole thing is called a photon. I mean, this is terrible vocabulary, and physics is doing nothing to fix it, because they want to keep the wave part. They'll keep mentioning Einstein proved, but they'll never account for what Einstein demonstrated.
Contained within each photon. So visible light does not have enough energy to break the bonds in our skin, so our skin will stay intact as sunlight hits our skin. But what about UV radiation? It has shorter wavelengths and more energy. What kind of wavelength UV radiation can actually have enough energy to break one of these bonds? Well, let's find out.
Well, it's not going to be hard to figure out, right? You're about 4% off the 3.4 number you need. 3.6, okay, so you're at 3.1. So you're about 10% short, a little less than that maybe, of the amount. So then you could just argue that if you're at 400 now, and you say 10% 40, so 310, 320 will be enough.
So now what we need to do is convert this to wavelengths. So a wavelength is equal to hc divided by the energy. So that's equal to 6.626 times 10 to the minus 34 joules times seconds, multiplied times the speed of light, 3 times 10 to the 8 meters per second, divided by the energy contained required to break a bond, which is 3.61 electron volts, which is this many joules. So that would be 5 points.
Right, so I mean, it just shows what mathematics is, right? Because the simple way to do it is just to figure out what percentage you are off. So you could just redo this math by just merely putting those two numbers, 3.6, 3.1. You know you're off by a factor of whatever that percentage is. So just take that number and do the percentage on the wavelength, and you'll get the right answer. I mean, you don't need to do all this 10 times 4 times whatever, blah, 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 blah crap.
78 times 10 to the minus 19 joules, and let's figure out what that is equal to. 6.626 e to the 34 minus times 3 e to the 8 divided by 5.78 e to the 19 minus equals, and we get 344 nanometers, which means if UV radiation makes it through to the surface of the Earth, and
right. So, I mean, the obvious answer, blah, 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 found just obviously without having to do all that much. But anyway, so So again, it's just about the frequency, and the frequency is dependent on the chemistry. So whatever the chemistry is will dictate what frequency you have to push at to add energy to move the electron. So it's how much tension the electron's in. So it's how strong. So unlike the pendulum argument, you could argue that this argument is like something on a stick, and it has a certain spring constant. So the atom dictates the spring constant of the stick, how much tension is in the stick, and that decides how fast you have to add your energy, because it decides how fast it comes back. And it's the rebound speed that is dictating the speed you need, okay, to the frequency, because the rebound speed plus the momentum you're adding. So the momentum is always constant. The photon's always moving the speed of light and always is adding the same amount of energy. So the only thing that's variable is the rebound speed. And that's why every chemical has a different resident frequency that it's going to absorb more readily, because it's the one that adds energy, and the frequency that's not going to add energy.
Small amount of it does, and it contains wavelengths of 344 nanometers or shorter. That usually radiation will carry enough energy.
So understand, and shorter. So the real point is this isn't. I'm cheating a little bit by saying this is about wobbling something, because it's really not. You don't get to wobble it. It's just a one-way kind of thing, and you're just defeating the rebound. So the idea is you have the thing on a stick, and you hit it. You move it to this position, all right? And now you need to hit it again if you want to add energy. So you hit it to a position. It could rebound a little bit, but the idea is you don't want it to rebound very far before you hit it again and move it further over here. So this is the point where now you'll create electricity, or this is now the point where you create a strong dipole, because now you've moved the distance between the electron and the proton. It's gotten farther, and by increasing that distance you've created more of a dipole, magnetically, whatever the function is for electricity. But the point is this is what you need. You need the electron to get to this position, and if you have a slower frequency, the idea would be this swings back too far before you hit it again, and therefore you can never get it to this position, because it keeps coming back. You hit it again, it just gets it to here. You hit it again, it doesn't do anything. It doesn't accomplish the task. And the task is this position, and you can only get there by adding energy, not causing more balance by hitting it when it's coming back at you. Will not get the job done of moving the object further away, and that's all there is. There's nothing. That's the simple mechanical explanation. They never say it, they never even talk about it, but that's the real tension that you're fighting, and that's why specific frequencies matter. And the faster the frequency, the more likely you're going to get the result, because the faster the frequency, you're going to keep hitting it while it's still moving in the direction you want to keep hitting it in. So it's it's like, I don't know, moving a car out of the mud is, see, you're rocking it, so that's a little bit of a cheat, but it's just like adding momentum to any system. It just works better if you hit it faster, because there's no rebound. You're never fighting the energy. You're always pushing more energy in. It's probably a better analogy, but don't have it at my fingertips.
Energy to break the carbon bonds in our skin, and that is what causes sunburns. Now, double bonds require more energy. Notice at 640 kilojoules, you'll need quite a bit more energy to break those bonds, and the UV radiation that makes it through the atmosphere and through the ozone layer will not contain photons with the energy required to break double bonds, but it will have energy required to break single bonds, and that is what causes sunburns.
Right. So, I mean, obviously the double bonds can be served. You could probably coincidentally break them now and then because you move both objects, consistently. But the problem would be is you could sort of understand that if you're trying to get rid of a double bond, you might be hitting one of them, but the other one's still lagging, and you have to get both of them to the distance far enough away for the atom to fall apart. And yeah, that's not likely to happen. But the idea would be is if you hit one of the electrons hard enough, you get it so far out of place that now the atom only becomes bound by one electron, and you could understand that that would make the bond itself weaker substantially. So I guess you could say that the two electrons are sort of dependent because they're connected to another nucleus, and they're kind of going to go with each other together. So if one goes, the second one's going to be more likely to go. That didn't say it right. If one goes far enough, the second one has to go. So if you can push one electron really far away, the other electron will go with it, because the nucleus is going to go with it.
So you can see we're safe with visible light, no problem there, but the UV radiation making it through can actually break the bonds in our skin, and that causes sunburns. And again, the reason why it works that way is because light is consistent of photons, and each photon carries that exact amount of energy, which can be impossible.
So again, each photon carries that exact amount of energy. It's a frequency, all right? And so it's just wrong way to say it. The bullets are always the same, and all you can do is change when you fire them. But that can matter. But you can't say the bullets don't have a quality that is independent of their frequency, because they do. They're the elemental part. The emergent part is how fast you fire them.
On objects by the interaction of the electric field and magnetic field oscillations, causing forces to exist on charged particles, causing to oscillate.
Correct. Causing forces, causing this, causing that, causing all a bunch of stuff they have no description for. It's just some virtual something, some imagined something, some never detected thing. Okay, fields of what? They're saying they have some elemental description, and their elemental description is there's a whole bunch of elemental functions creating their elemental function. I mean, they're not getting to the source of anything, because they're blaming it on a whole bunch of other functions.
Back and forth, and if the oscillation is violent enough, then those will then break the carbon bonds inside the skin of our bodies. Amazing thing. Good thing that only a very small amount of that UV.
Yeah, just a story, okay? An amazing story. It's not even amazing, it's silly, but whatever. Silly story.
Radiation actually makes it through, otherwise we'd be in a lot of big trouble. All right, that's how that works.
It doesn't work that way. So that's his assertion that that's how it works. It's not how it works. I don't think that's a good explanation. It's certainly not a proven explanation. They don't admit that, well, this is just something we made up based on a little tiny bit of evidence that we do have. We've concluded that it's this wacky story instead of, a simple story. Yeah. That's all. They're just not honest about how they just made this up. That, well, yeah, probably if you did think about it, you can think of better ways than this wavy crap theory. It's just the wavy crap theory. It's just, it's not some spectacular theory. It's a wavy crap theory. Yeah. So, till next time and such, I guess. It was a semi-related, comment, but it was just so bad, and I sort of want to make a more spectacular, maybe I'll actually type a reply to it. So Eric's electrons, I've mentioned this before. He doesn't do videos on physics. He complains about black racism or some other kind of crap. But everybody can have their own priorities. I'm just saying it's not really, his title isn't really what his channel's about. So he's a physics student, I think, still. And so anyway, but this is just such a bullshit comment. I mean, it's just so fucking weak and so lame. You're completely redefined what a photon is to fit your hypothesis. Well, where do you have any evidence of that? Because you've got it completely backwards. I mean, I've already told the story. One of the major reasons why I said these guys are full of shit is because of their photon theory. Okay, it was the one that I said this is silly. It's this wavy crap bullshit explanation. It's where physics went way sideways for me as a kid. I said, okay, you can't trust these guys because they'll believe any kind of woo. I mean, that's a silly explanation, okay? I mean, something snaking through space, no explanation for how it does that. Where's its snake muscles? What the fuck is that shit? And they didn't say, well, we think that the universe is really just a bunch of steel ball bearings, you see, and we push one ball bearing and they all move into the other ball bearings or something. They didn't even have any way to make this wave. Like, they could have said, oh, it creates more pressure. It's not really a wave. It's just that it's a thing, okay, and it pushes into the other things and pushes them out of the way. They didn't even come up with an ether theory. There was nothing. They just, this silly wavy thing. Nothing. No explanation for this. And so somehow the ball bearings going this way are electric ball bearings, and somehow the ball bearings going this way are magnetic ball bearings. I mean, nothing. Just nothing. Okay, so even if your stupid comment, your stupid assertion was in some small way correct, that is, somehow I decided one thing was true and then I tried to make everything fit that, you have it exactly backwards, asshole. Okay, so your accusation is not only unfounded in the sense you have no evidence that that's exactly how my hypothesis was created, and then you certainly have no evidence that if it was the way it was created, it was the order you say it was in, when it was exactly the opposite order. All right, anyway. And you did not even mention both a photon and an electron are elementary particles. I'm supposed to say that in every video. I didn't hear him say it. I played 2 of his videos. He didn't say in one of those videos that photons were elementary and electrons were elementary. Didn't say it. Every video I have to say that? I have to assert that in every single fucking video? Are you going to find fault because you think I don't know that, asshole? You think I've asserted something else? Did I imply anything else? Where did I imply that photons aren't elementary? Where did I imply that electrons have only something besides a standard function? I mean, bullshit alert all over the place. I mean, what the fuck? This is the best you can do? You've got a semi-half of a college education and this is the best you can do as a fucking argument? Lame as fuck. Okay, anyway. Both photon and electron are elementary particles. This is beyond pseudoscience territory. And you don't see that as an insane exaggeration. Because I didn't say they're elementary particles. Oh, I'm a pseudoscience now. I mean, the whole video is pointing out how your science is the pseudoscience in the sense there's no scientific method here. You're not being Newton and saying, I don't know what causes gravity. You're saying you do know. You do know the answer. And your answers are silly. Magical fields do it. Oh, there's this field of stuff. We don't know what it is. It's a magical field thingy. And the magical field thingy causes things to move and vibrate. And then your explanation for gravity is, oh yeah, it's another magical field, okay? And we're not gonna call it the magical field. We're not gonna say the magical field is bent, okay? No, we're gonna call it space. We're gonna take a word that already had a definition, which was nothing, okay? Space was nothing. That was the nothing that made the somethings visible, because they stuck out, because they're in the middle of nothing, and there's something that was just fucking obvious. And you turn nothing into something, into another field of nothing that knows how to tell stuff where to go through this magical process of telling it where to go. But it's elementary, of course. It's an elementary thing, right? Bent space is elementary, even though you've given it properties and functions and no explanation for how it has those functions. How does it function? Oh, there's no explanation as far as it's elementary. It's only elementary because you don't have any explanation whatsoever. You just have a magical force. Just a magical thing happens and it magically moves. I mean, this is amazing. Just how can you sit there and type absolute shit of this magnitude, where you have debunked not a single sentence I've spoken. You have explained how I am wrong about nothing here. You have defended nothing of your whack physics, your woo physics, your imaginary little friendly fields that move things. Nothing. And you'll call somebody else a pseudoscience. You don't see how you're just a slandering, rude, obnoxious pile of fucking shit. I mean, how do you have the right to sit there and throw the word pseudoscience around? I mean, it's like that's sort of like it's almost like a racism. I mean, it's almost like it's an incredibly derogatory statement that you're making based on no fucking evidence. None. No argument, no explanation. You just hate pseudoscience, and you're going to call anything that doesn't agree with you a pseudoscientist. Is that it? So, if you don't have blue eyes and blonde hair, I should just call you a subhuman? Is that fair exchange? I mean, fuck you. This was so lame. Just so lame. And you'll make a video about how you have some perspective on life, that somebody should listen to you, and this is your behavior. This is how you debunk somebody with this shit, this lame shit. Fuck you. All right. Pitiful. All right. Until the next time. And such.